we're churning through calories at about 20% more per day than chimpanzees and bonobos, which are the most closely related group to us. And then we're also burning even more energy compared to gorillas. Gorillas are a bit lower than chimps and bonobos. And then orangutans are their own really interesting story. Orangutans seem to be one of the lowest metabolic rates ever measured for any placental mammal. So marsupials are kind of strange. That's a fun conversation maybe for another day. But if you look at non-marsupial mammals, orangutans are the lowest ever measured, except for sloths and pandas. So really low metabolic rates in orangutans. But humans, the human story is we're the fastest metabolic rate. We're the high energy ape compared to all of our other ape relatives.
And you said, so we have high total energy expenditure compared to other primates, controlling for body size. Yeah. Maybe we should briefly mention when you just look across the animal kingdom, what's the general relationship between metabolic rate and body size, and why is that important to consider here?
Yeah. So, where does your metabolic rate come from? Why do you burn calories at all? Well, all of your cells are burning energy all the time just to do their daily functions. And so, the more cells the more energy you're going to burn. So, mice don't burn as many calories every day as an elephant does, right? Just because a mouse is tiny, doesn't have many cells compared to an elephant. Elephant's made up of many more cells and therefore just burns more calories, just by virtue of being bigger. And so it's an interesting sort of relationship, actually. It's not one-to-one. So you might think that, let's just use some toy numbers. If a 1 kilogram animal burns 100 calories a day, you might expect that a 10 kilogram animal would burn 1,000 calories a day, 10 times more. But that's not actually what you see. There's like an economy of scale. So the animal that's 10 times bigger will only burn like 7 times more energy, right? So somehow they're kind of saving energy there. There's like an economy of being bigger. And it follows a power law that's very well known since the 1930s, called Kleiber's law. So that the total energy you burn every day increases with metabolic rate to the 0.75 power. We can get into the math of that if we want to. But anyway, so we have to control for body size in any analysis we do, because bonobos and chimpanzees are much smaller than your typical human. Male gorillas are much bigger. Orangutans can be kind of around the same size or bigger or smaller. So you have to control for body size in any analysis of energy expenditure. And you have to do it in a smart way, because that power law kind of curved relationship.
It's not one-to-one.
Exactly.
Yeah. This is very consequential, right? Like if you were to just naively scale things 1-to-1 and say dose an animal with a drug and say, it's 10 times bigger, let's give it 10x the dose, that's going to become very consequential and even life-threatening.
Oh, 100%. Yeah, that's exactly right. So there's all sorts of reasons that we have to understand this relationship. It's also why, by the way, if you ever see somebody looking at the kilocalories per kilogram, right? You see people trying to kind of account for body size by just dividing your body mass by how many calories you're burning. If you ever see that simple ratio, that should be a red flag, because that ratio assumes a one-to-one relationship.
Right.
And when there isn't a one-to-one relationship, you can kind of get funny answers. So FYI.
Yeah.
Buyer beware.
Okay. So controlling for body size, humans have something like 20% higher total energy expenditure than we might expect otherwise compared to other apes.
Compared to other apes. That's right. So, so it was awesome because we finally had an explanation for how can we do all these expensive things?
More energy.
That's the how, right? It doesn't necessarily tell us the why. That's an interesting evolutionary story. But finally, we had an actual physiological explanation for how, because we didn't have that until this work came out.
And so let's dig into this a little bit more. One of the other things you look at is the relationship between free fat mass and total energy expenditure across ape species. What can you tell us there?
Yeah, so fat-free mass is kind of just what it sounds like. It's how much body mass you have minus your fat. And the reason we do that, we look at that measure, is that, like we said before, different organs, different tissues are, don't all burn the same number of calories per day. Fat is really quiet. It doesn't do much metabolic work. And so if we just look at your total body weight, that's not the best kind of measure of your metabolic size, if you want to think about it that way. Your best measure of size in these metabolic comparisons is fat-free mass.
And that would be really important if the proportion of body fat differed between species, I would imagine.
Yes, and it does, by the way. And so early work looking at just basal metabolic rate, that resting metabolic rate measure in humans and other apes, had found kind of misleadingly that there wasn't really a difference between humans and other apes. And that's because humans actually carry a lot of fat. We're not just the highest energy ape, we're also the fattest ape, which is
Hmm.
kind of fun to think about. And so, a 50 kilogram human, 110 pounds, had the same basal metabolic rate as a 50 kilogram chimpanzee, more or less. And so people said, oh, well, look at that. Humans are no different than other apes metabolically. Not true, because humans carry a lot more fat. And so actually, if we had exactly the same metabolic profile, our tissues were all burning the same number of calories as each other. Humans should have a lower metabolic rate
Right.
at that 50 kilogram body size.
Right. How much more
Effective, yeah.
fat do we have, and where is that fat mostly? Is there a pattern there?
Yeah. Well, so humans, a healthy human male adult might carry between 15 and 25% body fat, let's say. More is usually okay, a little bit more, too much more, and you have obesity issues. Less than 15 or certainly less than 10%, and you're a little bit too lean, typically, what people think.